Hello everyone, welcome back to JDCodebase. Today is day 19 of our LeetCode 75 study plan challenge. And today we are going to solve LeetCode number 724, find pivot index. Don't worry if you are new to coding or arrays, like these type of problems. I will explain everything from the scratch, and by the end of this video you will learn what a pivot index means and how to think about these type of problems and how to solve it efficiently in the big of n time complexity. And let's start with the read the problem statement. Given an array of integer nums, calculate the pivot index of this array. The pivot index is the index where the sum of all numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index right. If the index on the left edge of the array, then the left sum is 0 because there are no element to the left. This also applies to the right side of the array. Return the leftmost pivot index. If no such index exists, return -1. See, read the problem statement deeply. So means don't read like just you are reading a textbook. Read like means what is given, what is the value conditions apply here. Like in this line, it is clearly mentioned that the pivot index is the index where sum of numbers strictly to the left side, strictly to the right side of the array, sum of all numbers strictly to the index right, and the current number is the bit in between of that. So let me simplify it. We are given an array nums 1 7 3 6 5 6. We need to find an index where sum of all number on the left, sum of all number on the right, that index is called the pivot index. Like here I have this array 1 plus 7 8, 8 plus 3 11, 6 plus 5 11. So the both are these are the equal, 11 is equal to 11, and the remaining element left here is the 6. So at index 3 the number is 6 and left side is 11, right side is 11, so both are equal. So answer here is the 3, means the third index. Now first think about the brute force solution. How you means whenever you see this type of problem, how you means conclude this, means leave it all about the prefix or suffix, these type of terms. Just think about the brute force. A beginners might think like for every index calculate the left side sum, calculate the right side sum and compare. That works, but for every position we scan the array again, and that becomes the big of n square, too slow for the large input. Like I start a for loop, that means 1 plus 1 3 6 5 5 6 means entire for loop traverse the whole array, and for every index like I am at this index, there is the no left side array, but there is the right side array is this. So I have to again I write a separate function that calculate the sum from the starting index to the ending index. I just pass the starting index and ending index and just get the sum and compare the left sum, the right sum every time. But this is the big of n square because first one is the outer loop that traverses the whole array, and in the inner loop we are again call the function and traverse the whole array again. So this becomes a big of n square and too slow for the large input. We need something smarter. The smart idea is like instead of calculating the right sum every time or the left sum every time, first calculate the total sum of the whole array, right? And for example, 1 7 3 6 5 6 is the total sum. Here is the 11 11 22 plus 6 is the 28 is the total sum. And now while moving through the array we keep track of this. So just a moment ago I said that keep the eye on this line, strictly to the left, strictly to the right, means there is a pattern that total is equal to sorry for the bad handwriting, and leftSum current plus right side. So these are the three things for the total sum. Means left side, the current element, and the right side. This is same. 1 plus 3, 1, 7 plus 3, 11. 6 plus 5 is 11. And the middle one is the 6. Means 11 plus 11 plus 6. So these are the three numbers I have. Now we can calculate the right sum just by apply small mathematics like that total minus left minus current is equal to right. Just a simple rearranging the element here means numbers here. So that is the key trick here. Like let me move here. Like I have this array 1, 7, 3, 6, 5, 6, and total here is the 28. At index 0, the left sum is the 0, and right sum here is the, just rearrange that element. Right sum here is the 28 minus current in left sum is the 0, right sum here is the, we have to calculate, and the current element is the 1. So what is the value here? 27. Does 27 is equal to 0 or not? Not equal. So update the left sum by adding this plus 1. Now 1 left sum is the 21. Oh sorry, 1. Now 28 minus 1 minus 7. Now again calculate. I get 28 minus 1 minus 7 is the 20. 1 is equal to 20, not equal. So again add this value. Now left sum is the 1 plus 7, that is the value 8. So again 28 minus left sum is the 8, and the current element here is the 3. 28 minus 8, 20, 20 minus 3 is means that is the 17. Now these value are the right sum, right? These are the right sum value. Now 8 is equal to 17, not equal. So we add this value. Now I just update the value. 1 plus 7 plus 3, 11. Wait. Now this time 28 minus 11, and current element here is the what is the current element? Wait, 6. How to, let me zoom out. Yes, so here 28 minus 11, and the current element is the 6. So what is the value here? 28 minus 11 minus 6 is the 11. Now see the 11 left sum, the right sum value, both are equal, and so we have to just return the current element. That's simple. Yes, so pivot index is the this third index, this value. Now how to write this into the code? Let me show you. Let me write here. So first we have to calculate the total sum. Total sum initial value is the 0. And start a for loop for let num of nums and total sum is equal to num. I get the total sum, means 28 value. So again declare a variable left, that is left sum, and start a for loop that start from the 0. Sorry, where is go? Let I equal to 0, I smaller than nums dot length and I plus plus, and now this time calculate the right sum. Just apply this formula, the total sum minus left sum minus current value. So here right sum is equal to uh, total sum minus left sum minus nums of I value. And if left sum is equal to right sum, means every time we have to check whether they are equal or not. If it is, then return the ith value. And after that, left sum uh, plus equal to nums of I, means we have to update the left sum also, right? Like here I just add the value like 0, then 1, then 8, then 11, means every time I just add this value. And if there is no leftmost pivot, means there is no such index exists, then return the -1 as they already said. And let's try to run the solution. Yes, it passed. Let's try to submit the solution. Yes, it passed all the test cases and our solution is submitted. Here, if you see, time complexity is the big of n. We loop through the array twice. First for the calculating the total sum, and second for the calculating the left sum and the right sum. But as these are the only not the nested for loop, so it's a big of n and very efficient solution. And space complexity also here is the big of n, because I'm using just a normal variable total sum, left sum or right sum, no extra array or hash map. And the big trick here is the instead of recalculating the left sum and the right sum every time, we use a formula, that is the right sum is equal to total sum minus left sum minus nums of I, and that formula comes from this line, left sum left plus right plus current index is equal to total. So this saves a lot of time and makes a solution optimal. So read the problem carefully every time, because answer is in the problem statement. And that is for day 19. Today we learn what is pivot index means and how to avoid the brute force and prefix sum style optimization, and how to solve it in the big of n square, because the brute force solution is the big of n square and we did into the big of n. So if this help you understand the problem, keep following along for the next LeetCode problem. See you in day 20.